Hello everyone, welcome to PMATH 833, the topic course on Abstract Harmonic Analysis. I'm your instructor, Bo Yu Li. In this short video, I'm going to give you a brief introduction of this course outline. And let me start by introduce myself. This is a picture of me. I graduated from Waterloo with a PhD in pure mathematics. I'm currently a postdoc at Waterloo, and I was previously a postdoc at the University of Victoria. And for this course, it's a topic course in abstract harmonic analysis. So harmonic analysis has a really long and rich history. It all started from the classical harmonic analysis, where, for example, when you did pure math 450 at Waterloo, you study these periodic functions on the real lines, and you consider their Fourier transform, and a lot of the information of your function can be deduced from its Fourier transform and vice versa. Okay, so that's kind of classical analysis or classical harmonic analysis. So later on, people realize, well, what we're really using about this analysis on the real line or these periodic function, basically we're taking a function on the unit circle. Well, how about let's replace the unit circle by an abstract group? Basically, the only thing we're using about unit circle is that it's a group. So that's kind of the idea behind abstract harmonic analysis. We no longer study functions on the reals, but functions on an abstract group. And of course, you need to talk about integral and also continuous functions. So you can define the integral with respect to some measure. Okay, so basically that requires your group to have some topology, first of all. So you can have a Borel sigma algebra. And then the group will have some kind of measure. Okay, so that's going to be the Haar measure we're going to talk about. So that's kind of the idea behind this entire course. And as we move on into this course, we'll see that if your group is abelian, then the analysis is quite similar to what you had in the classical sense. Okay, so you have some analog of the Fourier transform, and a lot of the property actually hold. But when you move on to some non-abelian group, things are getting more complicated, and we're going to look at later in this course. So I just want to point out that this is really the foundation towards actually several quite active research directions. So if you're a graduate student, you probably already have a supervisor, and this is really help you decide what direction you like. So first of all, like I said, is abstract harmonic analysis itself is a really active area, just analysis on groups. And recently, there's also some analysis on groupoid. So groupoid is essentially just like a group-like structure, but you're allowed to have multiple units, and your multiplication is only defined partially. And they also have some techniques from these locally compact group analysis. Okay. So that's certainly one research direction. In Waterloo, we have a pretty good research group on this direction. So Professor Mikko Sprang and Brian Forrest, they're expert in this field. And on the second level, the very related is this analysis on Lie groups. We have a Lie group course at Waterloo, and I will talk slightly about some subgroups of the general linear groups. But if you want to learn more about Lie groups, there's a special course, you should take that. So Lie groups are basically very nice topological groups. Their topology we'll talk about in the first lecture. Basically, their multiplication and inverse are not only continuous but actually smooth. Okay, so that's kind of the nice part of Lie group. So they're related to geometry and a bunch of other stuff. Okay, so analysis on Lie group is again a very interesting area of research. And somehow related to Lie groups is that if you consider the unitary groups, so let's say you take all the n by n unitary matrices, that's a Lie group on its own. And if you want to say, how about let's randomly take one? Okay, so what do I mean by random? Well, you should have a probability measure on the set of unitaries, and this probability measure, well, we'll see is basically the Haar measure. And that gives you the basis for taking a matrix at random. So that's kind of the basis of the random matrix theory. And as it turns out, random matrix is really related to this new notion called free probability in operator. Okay, so somehow when the matrix size goes to infinity, the eigenvalue distribution somehow looks like something of a free probability. And in our department, Professor Andrew Nika is an expert on this field, so feel free to talk to him. And finally, these analysis technique we have can be often used in group dynamical systems. So a group dynamical system is essentially you have a group acting on some space. Okay, so it's originated from physics, where you have some physical dynamical system. For example, you have some bodies and they interact with each other, and as the time move on, they move. So that's kind of the group dynamical system. So this one is certainly related. It's a really hot topic. Dynamical system on its own is quite interesting. It's related to several other areas. I came from an operator algebra background, so I can only tell you what's the application in operator algebras. So that's a big field of study. So you study how group act on these spaces. Okay, so that's kind of related. And in our department, Matthew Kennedy is also an expert on this field. So I hope this course lays the foundation towards these research directions. And if you're interested in doing research in any of these, feel free to talk to these professors. They will give you some better idea of what's next after this course. All right, so let me briefly talk about the prerequisite. I hope you all have the prerequisite. So first of all, you need a course in functional analysis. In Waterloo, that's PMATH 753 or 453 or equivalent. Also a major theory course for 51, and also some background in point set topology. So I'm not going to talk too much about these backgrounds. So if you have some problem, feel free to ask me. And if you're rusty on some of these topics, I know I am. So here are always two good references I always use. So first of all, the PMATH 753, the course note by Laurent. He covers basically everything you need to know about functional analysis. And of course, he also he's introduced the topological vector space, and he has a little appendix on topological vector space and topology spaces, subbases, those kind of stuff. You feel free to read his course note. And if you're rusty on measure theory, you can look at the course note by Ken Davison. All of these course notes are free on their website. Feel free to email me if you cannot find them. All right, so let me talk about textbook. So there's no required textbook. I'm following these three textbooks. I may mix in some other references from time to time, but I'm mainly following a full-length book, a course in Abstract Harmonic Analysis. It's pretty well-written book. All the full-length books are really pretty well-written. And the second book is this huge book, Abstract Harmonic Analysis, Volume 1 and 2 by Hewitt and Ross. It basically covers everything you need to know. It's a super big book, contains a lot of stuff. Okay, so there's no way I cover even half of that. Okay, so there's if you want to have some more reference, and it's always a good book to read. And finally, there's a book by Loomis on Introduction to Harmonic Analysis. I may use it from time to time. All right, so let's talk about grading. So this is a graduate course. We don't have a final exam. So the grading will be 80% on assignment and 20% on talk. Assignment, I'm trying to make it bi-weekly, but I say bi-weekly, but I'm probably not going to do that because this course is quite hard, and we may not have time to do bi-weekly assignments. So roughly, you would expect between 4 to 6 assignments, I would say. Okay, the assignments are due on Chrommark, and this course, as you may notice, is entirely online. So we're not going to meet anywhere on campus. Okay, so I will send out the Chrommark link, and you scan the stuff, and then all the marking stuff are going to be on Chrommark. And we're going to have a Piazza forum, and I'll talk about that later. But if you have any question about your marking, feel free to email me or ask me on Piazza. And finally, there's 20% component of a project. So I'll provide a list of potential topics near the middle of the term. And essentially, you need to read some research paper or a certain section in the book. And then you write a short summary and do a 30 minutes presentation at the end of the term. Okay, so that's kind of a common component in graduate courses at Waterloo. So I will give you more information near the later half of this term. All right, and about office hour and help, I will hold office hour on Zoom, probably starting in the third week. I will post the Zoom link on Learn, and everyone can join. If you just want to join and listen in, feel free to do that. And there's also going to be a discussion forum on Piazza. If you have any questions, feel free to post there. And feel free to answer other students' questions. That's always encouraged. And in case you need any extra help, feel free to email me directly. We can set up a separate Zoom link, or we can meet up somehow, all right? All right, so that's everything I want to talk about for the introduction. So I hope you enjoy this course.